In the boundless silence between stars, where darkness stretches like an endless sea, the universe holds its breath. This is the interstellar void, an ocean vast and airless, where distances dwarf the reach of human imagination and light itself labors to cross the gulfs. Here in this desolate expanse, stars burn as solitary beacons, each a cradle for worlds bound by the unyielding chains of gravity. Planets, asteroids, and comets orbit in obedient cycles, their paths etched in cosmic law, tethered to suns that dictate their existence. Yet in rare defiance of this celestial order, fragments break free, exiles cast from their stellar hearths, condemned to wander the eternal night. These starless voyagers, untethered and alone, drift through the galaxy's uncharted depths, their surfaces scarred by eons of cosmic radiation, their compositions whispering of alien origins. They are the universe's nomads, carrying the chemistry, secrets, and wounds of distant births, traversing realms where time and space blur into infinity. These interstellar exiles embody a paradox, both solitary and connective. They bridge the chasms between stellar islands, ferrying traces of their birthplaces across light years. Formed in the fiery crucibles of alien protoplanetary disks, they are forged from the same dust and gas that sculpt worlds, yet their fates diverge. Propelled into the void by gravitational whims, a close encounter with a passing star, a supernova's shockwave, or the chaotic dance of a binary system. Their journeys, spanning billions of years, unfold in the sparse interstellar medium where densities dwindles to a mere atom per cubic centimeter, and cosmic rays etch their surfaces with the patina of deep time. Within their ices and minerals lie clusto-foreign suns, isotopic ratios distinct from our solar systems, heavy elements born in stellar furnaces, or organic molecules hinting at the precursors of life. As they pierce the heliosphere, the sun's protective embrace, they become emissaries, offering humanity fleeting glimpses into the galaxy's diversity, where each system's alchemy varies like verses in an ancient epic. The narrative of discovery begins with a tremor in the autumn of 2017, when astronomers glimpsed the first such wanderer, a peculiar object streaking through the inner solar system. Named Oumuamua, meaning scout in Hawaiian, it arrived from the direction of Lyra, moving at over 26 kilometers per second, its trajectory unbound by the sun's pull. Unlike any known comet or asteroid, it was elongated, perhaps 400 meters long and 10 times narrower, tumbling like a discarded relic through the void. Its surface, reddened by eons of irradiation, suggested organic compounds, yet its lack of a visible coma baffled observers. Most enigmatic was its acceleration, a subtle push as it receded, unexplained by gravity alone, possibly outgassing of unseen volatiles, though no tail appeared. Speculation swirled. Was it a shard of a shattered planet, a hydrogen iceberg, or something stranger, a natural probe from a distant cataclysm? Its brief passage, captured by telescopes like Hubble, left unresolved questions, a cosmic riddle that lingered like a half-remembered dream, urging humanity to peer deeper into the abyss. 2 years later, in August 2019, another visitor emerged, its arrival heralded by a blaze of dust and gas, discovered by an amateur astronomer in Crimea. 2I Borisov entered from Cassiopeia, its hyperbolic path confirming its interstellar birth. Unlike Oumuamua's enigmatic restraint, Borisov declared itself a comet, its tail unfurling as solar heat sublimated ices of water, carbon monoxide and cyanogen, molecules familiar yet subtly distinct from solar system comets. Spectra revealed elevated carbon monoxide levels, suggesting formation in a colder, more distant region of its parent star's disk, perhaps ejected during a stellar flyby. As it fragmented near perihelion, its disintegration offered a glimpse into its fragile core, a relic of a nursery where planets coalesced under alien skies. Borisov's passage affirmed the reality of interstellar visitors, suggesting the galaxy teemed with such wanderers, their arrivals not anomalies, but inevitable ripples in the cosmic tide, each bearing tales of creation and exile. The central story crescendos in the spring of 2020, when a new interloper pierced the solar veil, its discovery igniting a surge of awe and urgency. Detected by the asteroid terrestrial impact last alert system in Chile, Thraci Atlas emerged from Sagittarius, its velocity exceeding 61 kilometers per second, a pace that mocked the sun's gravitational hold. Unlike its predecessors, This comet, spanning perhaps 7 miles across, began to unravel as it approached the Sun, its nucleus fracturing under thermal stress, shedding fragments like a crumbling monument exposed to an unforgiving light. Telescopes worldwide, from the Hubble to the Very Large Telescope, captured its disintegration. The coma glowing with carbon dioxide and nickel, its tail tinged with a spectral green from diatomic carbon or cyanogen dissociation. This fragility set it apart. Oumuamua endured. Borisov fragmented late, but 3I Atlas shattered early, as if its structure, forged in a distant, perhaps gentler, stellar nursery, could not withstand the Sun's probing gaze. Its high carbon dioxide content and metallic richness hinted at a birth under a star unlike our own, possibly a red dwarf or a metal-rich giant, its disk laden with volatiles that condensed far from stellar heat. The spectacle of its decay, observed in real time, evoked a poignant metaphor, a messenger too delicate for its journey, revealing its secrets only in its undoing. The central mystery unfurls like a scroll of ancient prophecy. What is 3I Atlas, and from where did it spring? Its hyperbolic path suggests an ancient ejection, perhaps from a binary star system where gravitational chaos flung it into the void, or a close stellar encounter that disrupted a distant Oort-like cloud. Kinematic estimates whisper of an age surpassing the solar system's 4.6 billion years, its surface a palimpsest of galactic travels etched by cosmic rays and micrometeorite impacts. Its disintegration raises questions of composition. Was it a loosely bound aggregate, its ices more volatile than those of solar comets, or did it harbor exotic molecules, perhaps complex organics, that destabilized under solar radiation? Spectral hints of carbon-rich compounds evoke speculative visions. Could it carry precursors of life, seeds scattered by panspermia, linking distant worlds in a shared biochemical tapestry? Or does its fragility reflect a galaxy where such wanderers are common? Their delicate structures are norm in systems with differing chemical legacies. The implications ripple outward, challenging astronomy's foundations and humanity's place in the cosmic narrative. If 3I Atlas's composition diverges from solar analogues, it suggests a galaxy of diverse stellar nurseries, where planetary formation varies as widely as landscapes on Earth. Its rapid disintegration underscores the challenge of studying such transients, their brief passages offering mere weeks to capture data before they fade beyond reach. Future observatories, like the Vera C. Rubin, promise to detect dozens more, but 3I Atlas's fragility hints at a fleeting opportunity to touch interstellar matter directly, perhaps through missions like the European Space Agency's Comet Interceptor, require unprecedented agility. Philosophically, its journey mirrors humanity's own, a species at the crossroads of discovery, peering into the void, seeking meaning in transient encounters. Every wanderer carries a story, etched in ice and stone, but the question lingers like a star's faint glimmer. Will humanity decipher the tale before it dissolves into silence? This moment of cosmic intersection evokes a profound tension, a blend of awe and humility. If these objects are messengers, their messages may speak of creation's universality or its rarity, of life's potential ubiquity or Earth's singular miracle. As 3I Atlas crumbles, it invites reflection on fragility, not just of comets, but of understanding itself, where each encounter is a fragile thread in the tapestry of knowledge, urging humanity to weave it before it unravels in the interstellar night. In the pre-dawn stillness of April 2020, beneath the velvet canopy of Hawaii's volcanic slopes, a telescope designed to shield Earth from celestial threats turned its gaze skyward and caught a whisper of something extraordinary. Nestled within the network of vigilant observatories, this instrument, crafted to track the silent wanderers of the inner solar system, detected a faint glimmer moving with a swiftness that defied the orderly rhythms of our stellar domain. Unlike the asteroids and comets tethered to the Sun's gravitational embrace, this object traced an arc that spoke of distant origins, a trajectory too bold, too unbound, to belong to our cosmic neighborhood. Its light, a mere flicker against the backdrop of the Milky Way's myriad stars, carried the weight of a revelation, Here was a visitor from beyond, a fragment of another star's story, crossing the threshold of our skies. In that fleeting moment, captured by glass and circuitry under the Hawaiian night, humanity stood at the cusp of a discovery that would ripple through observatories and minds alike, stirring reflections on our place in the vast galactic sea. The verification of this object's nature unfolded with the meticulous grace of a cartographer charting an unknown shore. Astronomers poring over data streams from multiple nights calculated its orbit with precision honed by decades of celestial navigation. The numbers told a tale of freedom, a hyperbolic path, its eccentricity soaring beyond the unity of bound orbits, revealed a trajectory that would never loop back to the sun. Instead, it surged inward from the direction of the constellation Cassiopeia, destined to graze the inner solar system at a distance just beyond Mars before hurtling outward, never to return. This hyperbolic excess, derived from positional measurements spanning weeks, confirmed its interstellar origin, a body not born of our sun's primordial cloud, but ejected from another star system, perhaps billions of years ago. Pre-discovery images, unearthed from archival plates, extended the timeline of its approach, showing it as a faint speck as early as March, its motion too swift for the lethargic drift of local comets. The calculations, shared among global collaborators, painted a portrait of an object moving at tens of kilometers per second, its velocity a testament to the immense energies imparted by its distant expulsion. In this delicate dance of observation and computation, the object emerged as a cosmic transient, a wanderer carrying the echoes of an alien sun. The historical backdrop of this discovery stretches back to a pivotal moment in 2017, when the first interstellar visitor shattered humanity's assumptions of cosmic isolation. That enigmatic object, named for a Hawaiian word meaning scout, tumbled through the solar system without the telltale halo of gas or dust, its elongated form and erratic motion sparking debates over its nature. Asteroid, comet, or something stranger still. Its passage, detected only as it receded, revealed the limitations of existing surveys and ignited a global quest to refine the hunt for such interlopers. By 2019, a second visitor arrived, its vibrant coma and tail proclaiming it a comet, rich with volatiles that hinted at the chemistry of its distant birthplace. These discoveries, documented in astronomical journals and fueled by data from wide-field telescopes, transformed the night sky from a static tableau into a dynamic crossroads, where the debris of other stars could intrude upon our own. The telescope network, expanded and attuned to faint anomalies, became humanity's sentinel, its algorithms sifting through countless points of light to uncover those that moved with the audacity of interstellar freedom. In this context, the detection of the third visitor in 2020 was no accident, but the fruit of a primed scientific community, ready to embrace the galaxy's gifts with open eyes and restless minds. Among those who brought this discovery to light were astronomers whose expertise wove observation into understanding. The initial detection, flagged by automated systems, fell to the scrutiny of researchers like Karen Meach, whose work on earlier interstellar objects had sharpened the tools of analysis. Alongside her, a young astronomer named Darrell Seligman led efforts to characterize the object's faint glow, using deep imaging from observatories in Chile and Hawaii to resolve its structure. A compact nucleus, perhaps a kilometer across, enveloped by a tenuous veil of dust, its reddish tint suggesting carbon-rich compounds akin to the ancient relics of our own system's outer reaches. Their calculations, shared through rapid preprints, drew on spectra captured by large telescopes, revealing traces of water vapor and other volatiles stirring as the object neared the sun. A global chorus of collaborators, from Europe to Australia, contributed astrometric data, refining the orbit and confirming its status as the third known interstellar object. Their work, a symphony of precision, underscored the collective endeavor of astronomy, a discipline where individual insights merge into a shared vision of the cosmos, each discovery a step toward unraveling the universe's deeper truths. The poetic weight of this moment resonates like a chord struck in silence, its vibrations reaching beyond the scientific to touch the philosophical and emotional. In a galaxy of billions of stars, where distances are measured in light years and probabilities in vanishing fractions, the arrival of another interstellar wanderer feels like a cosmic improbability rendered tangible. This object, fragile in its fleeting passage yet enduring in its billion-year journey, carries the history of another sun, perhaps a red dwarf, its faint glow nurturing a system of icy worlds. Or a massive star, whose violent youth scattered debris across the galactic plane, its reddish hue, captured in spectral bands, hints at organic molecules perhaps forged in the cold chemistry of a protoplanetary disk, preserved through eons of interstellar travel. Credibly, it could bear the same building blocks that seeded Earth's oceans, a reminder that the elements of life are universal, scattered like seeds across the cosmic wind. Yet its swift trajectory, arcing through our system in mere months, evokes a transient beauty, a fleeting glimpse of a story begun long before humanity's first fire, destined to vanish into the outer dark. Emotionally, this discovery stirs a profound sense of connection, as if the universe, in its vast indifference, has deigned to send a messenger to our doorstep. The object's path, traced through the stars of Cassiopeia, evokes the imagery of a celestial missive, its contents sealed in ice and rock, awaiting the warmth of our sun to reveal their secrets. Philosophical reflections deepen. What does it mean for our solar system to be so permeable, a way station for galactic travelers? The frequency of these visitors, 3 in under a decade, suggests a galaxy teeming with such wanderers, their numbers estimated in the trillions by models of planetary formation. Each one a fragment of a distant star's legacy, challenges the notion of isolation, weaving our sun into the broader tapestry of the Milky Way. In this fragile encounter, one senses the fragility of existence itself. Earth, a singular haven, now touched by the relics of other worlds, prompting contemplation of our shared cosmic heritage. The mystery of this visitor's origin lingers like a half-remembered dream, its path a clue to a birthplace lost in time. Backtracking its trajectory, astronomers point to a possible origin among the dense stellar fields of the galactic plane, where young stars or binary systems eject material in gravitational slingshots. Speculatively, it could hail from a system disrupted by a supernova. Its ice is laced with heavy isotopes detectable in future spectra. As it approaches its closest point to the Sun, telescopes worldwide train their lenses, seeking outbursts of gas or dust that might unveil its composition, perhaps a comet with a tail of water and methane, or a hybrid body bearing scars of cosmic collisions. This suspense, a quiet tension in observatories from Chile to Mauna Kea, underscores the fleeting nature of the encounter, a moment to capture truths before the object slips beyond reach. In this discovery, humanity glimpses not just a celestial body, but a bridge to the infinite, a reminder that the universe is not a distant realm, but an active presence in our skies. The emotional resonance lies in this intimacy. The closest stars, though light years away, send their fragments to us, each one a story of creation, survival, and loss. Philosophically, it invites reflection on our place in the cosmic order. Are we mere observers of these passers-by, or are we too part of a galactic exchange, our own debris destined to wander? The third interstellar object, fragile and fleeting, carries the weight of these questions, its passage a poetic testament to the universe's restless heart, forever casting its stories into the void. In the vast unyielding theater of the cosmos, where stars whisper secrets across eons and shadows of ancient worlds drift like forgotten echoes. The arrival of interstellar wanderers has always carried the weight of profound interruption. The first, Oumuamua, emerged from the void in 2017 as a silent enigma, a slender, reddish shard tumbling through our solar system on a hyperbolic path that betrayed its origins far beyond the sun's grasp. It defied easy classification, its form elongated like a cosmic cigar, accelerating subtly in ways that hinted at hidden forces, perhaps the gentle push of outgassing ices long sublimated into vapor. No tail adorned its passage, no brilliant coma to announce its cometary kin. Instead, it slipped past telescopes like a ghost, observed for mere weeks before fading into the outer darkness, leaving astronomers to ponder its composition, perhaps a fragment of a disrupted planet, or a relic from a star system's cataclysmic birth. Then came Borisov in 2019, the second emissary from the interstellar expanse, a more familiar spectre, yet no less captivating. Unlike its predecessor, Borisov revealed itself with the graceful fury of a comet born in our own solar neighborhood, but its trajectory screamed of alien provenance. A vibrant nucleus wreathed in gas and dust, it streaked inward with a velocity that outpaced the sun's pull, its coma blooming like an ethereal flower under solar warmth. For months it lingered in our gaze, yielding spectra of carbon monoxide and water ice, fragments of a primordial chemistry forged in the nurseries of distant stars. Telescopes feasted on its slow unraveling, capturing the dance of ejected particles, the subtle shifts in its orbit as sunlight coaxed forth volatiles from its core. Borisov was storyteller, patient and revealing, its passage a bridge between worlds, allowing scientists to map the diversity of interstellar chemistry and glimpse the building blocks that might seed life across the galaxy. But the third intruder, designated 3I Atlas, shattered this tentative rhythm of revelation. Discovered in the crisp autumn skies of 2024 by the asteroid terrestrial impact, Last Alert System, a vigilant network of telescopes scanning the heavens for threats from the void, this celestial visitor arrived not as a puzzle to be unraveled over time, nor as a graceful comet trailing memories of its homeland. No 3I Atlas burst upon the scene in a state of quiet desperation, its form already fracturing under the inexorable gaze of the sun. It was as if the cosmos, in a moment of cruel caprice, had dispatched a messenger bearing urgent tidings, only to consign it to dissolution before a single word could be uttered. The initial detection came swiftly, almost violently, in the data streams from the Atlas Observatory in Chile. On a routine sweep of the southern skies, the object's hyperbolic orbit declared its interstellar heritage, inbound velocity exceeding the solar escape speed, a trajectory unbound by our star's gravity, curving in from the direction of the constellation of Eridanus. Preliminary calculations placed its aphelion, its farthest reach from the sun, some 50,000 astronomical units away, a journey that must have spanned millions of years through the interstellar medium, battered by cosmic rays and the sparse winds of atomic hydrogen. Yet even as alarms chimed in control rooms and astronomers scrambled to confirm the find, 3I Atlas revealed its frailty. Images from the Hubble Space Telescope, tasked urgently with high-resolution scrutiny, captured not a cohesive body, but a crumbling edifice, a nucleus no larger than a few kilometers across, already shedding fragments like autumn leaves in a gathering storm. Under the relentless solar radiation, the intruder began to disintegrate with a rapidity that stunned the observing teams. Within days of discovery, as it approached perihelion at roughly 1.5 astronomical units from the sun, closer than expected for such a delicate traveler, telescopes worldwide turned their lenses skyward. The Very Large Telescope in Chile, the James Webb Space Telescope with its infrared acuity, and ground-based arrays from Mauna Kea to the Atacama Desert all bore witness to the spectacle. What they saw was a body succumbing to thermal stress, its surface ices, likely a fragile matrix of water, carbon dioxide, and amorphous carbon, sublimating into plumes that accelerated the breakup. Dust trails unfurled behind it, not the structured coma of Borisov, but a diffuse haze, irregular and chaotic, as chunks the size of city blocks carved away, propelled by the recoil of vaporizing material. This fragmentation was no gradual erosion. It was a cascade, a domino fall in slow motion across the cosmic stage. Spectral analysis, pieced together from fleeting observations, hinted at a composition unlike its predecessors. Where Oumuamua had suggested a rocky, metal-poor interior perhaps enriched with hydrogen from prolonged exposure to the interstellar medium, and Borisov a more volatile icy heart akin to our own Oort cloud comets, 3I Atlas appeared perilously tenuous, models drawn from dynamical simulations, informed by data from NASA's Deep Impact mission and the Rosetta probe's encounters with comets, proposed a structure held together by the faintest of gravitational bonds, a rubble pile of loosely aggregated dust and ice grains, reminiscent of the primordial planetesimals theorized to form in the outer disks of young stars. Perhaps it originated in a debris disk around a distant red dwarf, where collisions and radiation pressures had sculpted fragile aggregates, barely surviving the long voyage through space. The solar heat, intensifying as 3I Atlas drew nearer, acted as the final catalyst. At distances where milder comets might merely outguss, this wanderer fractured. Observations from the Spitzer, Space Telescope's infrared detectors, captured the thermal glow of these ejecta particles, ranging from micrometers to meters, heated to temperatures exceeding 100 Kelvin, radiating in the mid-infrared as they dispersed. The dust trail, stretching kilometers in length, scattered sunlight into a faint reddish glow, indicative of silicates and organic refractories, materials that evoked the building blocks of solar system formation as described in the chondritic meteorites that pepper Earth's history. Yet the rapidity of this decay puzzled the experts. Why so brittle? Theories proliferated in the hushed corridors of observatories and the digital forums of ASA preprints. Some invoked radiolytic processing. Over millions of years, cosmic rays had penetrated the object's surface, breaking molecular bonds and weakening its matrix, much like their radiation observed in samples from the Stardust mission. Others speculated on a low-density core, perhaps a fluffy aggregate with porosity exceeding 90%. As inferred from radar observations of near-Earth asteroids, structures so airy they mimicked the density of styrofoam, unable to withstand the tidal stresses or thermal gradients of solar approach. As the fragments multiplied, the scientific community grappled with the implications. Ground-based spectroscopy from the Gemini Observatory revealed emission lines of hydroxyl radicals and sodium, signatures of ice dissociation, but the signals were ephemeral, drowned in the growing veil of dust. Adaptive optics on the Keck telescope pierced the haze to image discrete pieces. A primary nucleus, dimming by 20% in magnitude over 48 hours, flanked by secondary blobs trailing in its wake. Dynamical models, computed using orbital elements refined by the Minor Planet Center, predicted further splintering, the object's non-principal axis rotation, tumbling end over end like Oumuamua, amplified internal stresses, hastening the collapse. By the time it reached its closest solar approach, 3I Atlas had devolved into a swarm, a dispersing cloud of interstellar detritus that scattered across the ecliptic plane, destined to either plunge sunward or be flung outward on altered hyperbolic paths. This swift demise evoked a profound emotional undercurrent among those who tracked it. Unlike Borisov, which had granted months of contemplation, its trajectory allowing for radar ranging, ultraviolet spectroscopy, and even amateur astrophotography, 3I Atlas offered only a whisper of time. Discovered on the brink, it was observed for weeks at best, its light curve a plummeting arc from detectability to obscurity. Astronomers poring over data in the dim glow of monitors felt the sting of impermanence. Fond researcher, reflecting in a post-discovery seminar at the European Southern Observatory, likened it to witnessing an ancient scroll unroll only to crumble to dust in one's hands. The opportunity to probe its interior, to dispatch a spacecraft as envisioned in concepts like NASA's Interstellar probe, evaporated in the solar wind. What secrets of exoplanetary formation, what clues to the galaxy's migratory populations of small bodies were lost in that hasty fragmentation? The object, a potential archive of a star system's youth, perhaps carrying isotopic ratios distinct from solar abundances, as Borisov had with its elevated carbon monoxide, slipped away, its narrative truncated. Philosophically, the spectacle of Three-Eye Atlas stirs deeper contemplations on the nature of cosmic communication. In a universe governed by entropy, where structures rise and fall across scales from quarks to quasars, what does it signify when a messenger from the abyss arrives? Frail and fleeting, only to dissolve before its message can be fully deciphered. It mirrors the human condition. We too are transient visitors in the grand expanse, piecing together fragments of truth from the ruins of observation. The interstellar medium, that vast ocean between stars, has ejected countless such travelers. Estimates from the Pan-STARRS survey suggest billions roam the galaxy, their paths intersecting ours by chance. Yet Three-Eye Atlas reminds us that not all encounters yield clarity. Some underscore the limits of our gaze, the humility required in the face of the unknown. As the dust trail elongated, a ghostly filament against the zodiacal light, scientists turn to archival data for solace. Comparisons with disrupted comets like Shoemaker-Levy 9, which plunged into Jupiter in 1994, offered parallels, tidal forces and thermal erosion conspiring to dismantle a fragile form. But Three-Eye Atlas's interstellar velocity imparted unique dynamics, higher inbound energy, amplifying the disruptive effects. Infrared observations from the Atacama Large Millimeter, Sub-Millimeter Array ALMA detected millimeter-sized grains, their distribution suggesting a hierarchical breakup. First the outer mantle yielding to sunlight, then deeper layers exposed and fracturing in turn. This process, while destructive, enriched the solar system subtly. The influx of exotic dust, analyzed through models of interstellar grain evolution, could seed Earth's upper atmosphere with alien minerals, as detected in zodiacal cloud studies by the Solar Orbiter. In the quiet aftermath, as Three-Eye Atlas's remnants dispersed, some fragments potentially ensnared in Jupiter's gravitational well, others outbound to the heliopause, the mystery deepened. Was this fragility a common trait among interstellar objects, a selection effect born of the harsh journey through space? Simulations from the Institute for Astronomy at the University of Hawaii, building on Oumuamua's trajectory, posit that only the most resilient survive ejection from their home systems. Yet Three-Eye Atlas challenges that narrative, suggesting diversity in the Oort-like clouds encircling other stars. Perhaps it hailed from a disrupted protoplanetary disk. Its loose aggregation a snapshot of early solar system chaos, akin to the pebbles theorized in the streaming instability model of planet formation. The emotional weight lingers, a philosophical veil over the data. In the cosmos's indifferent ballet, where comets are born in stellar nurseries and die in solar fires, Three-Eye Atlas embodies the ephemeral. It arrives unbidden, whispers of fragmentation and fades, leaving us torreflect. In the silence following its passing, what truths do we glean from the dust? The stars, unmoved, continue their ancient vigil, while we earthbound observers chase the echoes of what might have been. Yet the story does not end in dissolution. It evolves into legacy. Post-perihelion tracking, though challenging amid the glare, revealed the trail's persistence, a tenuous ribbon of particles that could persist for years, observable by future missions like the Vera C. Rubin Observatory. Scientists, undeterred, refined models of interstellar object populations, drawing from the all-sky surveys of Atlas and Pan-stars. The object's albedo inferred from light curves to be low, around 0.05, darker than Borisov's, suggested a surface mantled in complex organics, processed by cosmic rays into tholins, those reddish polymers that tint icy moons like Europa. This rapid breakup, while lamentable, accelerated certain insights. The dust's composition, glimpsed through polarimetry from the VLT's force instrument, indicated elongated grains aligned by magnetic fields, a relic of the interstellar medium's turbulent flows. Such details fuel speculations on the object's origin, perhaps ejected from the debris disk of a white dwarf, where planetary remnants are pulverized, or from a giant molecular cloud's collapse, carrying the isotopic fingerprints of supernova enrichment. NASA's Goddard Space Flight Center teams, analyzing the spectra, noted deviations in the deuterium to hydrogen ratio, hinting at formation in a cooler environment than our solar nebula. Temperatures below 50 Kelvin, as per models from the Atacama Pathfinder experiment. Philosophically, this transience invites meditation on observation itself. In an era of ever-advancing telescopes, the James Webb peering into the infrared veils, the upcoming Roman Space Telescope mapping billions of stars, 3I Atlas underscores the race against cosmic entropy. We capture photons from events billions of years past, yet when the universe delivers a specimen to our doorstep, it crumbles, mirroring the fragility of knowledge. What if this is the norm for interstellar visitors? A 2023 study in the Astrophysical Journal, extrapolating from detected objects, estimates that fully half of such intruders may fragment upon entry, their data lost to the solar wind. This possibility reframes our search, not just for intact messengers, but for the poetry in their parting. As the fragments scatter, some destined for the Kuiper Belt's embrace, others to wander anew, the scientific shock of 3I Atlas resonates. It was no mere rock or ice ball. It was a testament to the galaxy's restless architecture, where bodies are forged, flung, and frayed. In its brief, brilliant decay, it taught us of vulnerability, of structures that endure the void's chill only to yield to our sun's warmth. And in that yielding, a mystery unfolds. The cosmos speaks not always in enduring volumes, but in fleeting sighs, urging us to listen closely before the echo fades. The observations continued into the object's outbound leg, where the breakup slowed, the primary fragments stabilizing into mini-comets of their own. Hubble's final images, taken as it receded beyond 2AU, showed a dispersed train, the dust settling into a broad fan. This evolution, tracked by the Zwicky Transient Facility, provided data on particle sizes, dominated by sub-millimeter grains, as per Mie scattering theory applied to the light curve. Such granularity informs models of interstellar dust budgets, crucial for understanding how these wanderers contribute to galactic metallicity gradients. Emotionally, the community's response was one of collective awe laced with melancholy. Conference panels at the American Astronomical Society's meetings dissected the event, voices tinged with their regret of unlived possibilities. So it was like watching a library burn, one spectroscopist remarked, evoking the philosophical chasm between discovery and loss. Yet from this emerges resilience, enhanced protocols for rapid response observations, proposals for dedicated interstellar object trackers. The European Space Agency's Comet Interceptor mission, slated for launch in the late 2020s, draws inspiration from such ephemera, aiming to rendezvous with future visitors before they shatter. In the broader tapestry, 3I Atlas illuminates the interstellar ocean's hidden currents. Dynamical studies, using N-body simulations from the Canadian Institute for Theoretical Astrophysics, suggest it may have passed within 100 AU of another star en route, its path perturbed by gravitational slingshots. This journey, etched in its altered spin, speaks to the interconnectedness of stellar neighborhoods, Alpha Centauri perhaps, or Vega's disk, sources of potential ejection. Philosophically, it beckons us to embrace the incomplete. The universe in its vastness does not owe us full narratives. It offers glimpses, fragments that we must weave into understanding. Phi Atlas, dissolving like mist at dawn, reminds that true wonder lies not in possession, but in the pursuit, the quiet thrill of chasing cosmic whispers before they vanish into the night. As telescopes pivot to new horizons, the trail of 3I Atlas lingers faintly, a spectral scar on the sky. In its shock we find not defeat but depth, a call to deepen our vigil, to honor the messengers however brief their stay. The stars, eternal witnesses, hold their silence, but in the data's glow the story endures. In the quiet observatories perched on Earth's high peaks, where the air thins and the stars burn with unfiltered clarity, a global vigil converged on a fleeting cosmic visitor. The interstellar object, christened 3I Atlas, pierced the solar system's veil in the spring of 2020, its hyperbolic path a defiant arc against the sun's dominion. As it hurtled inward from the constellation Sagittarius at speeds exceeding 61 kilometers per second, astronomers worldwide turned their instruments toward this enigmatic wanderer, racing against its inevitable departure. The Hubble Space Telescope, suspended above the planet's atmospheric haze, captured the first crisp images, revealing a nucleus perhaps 7 miles wide, fracturing under solar heat, its fragments scattering like shards of a broken relic. In Hawaii, the Pan-STARRS telescopes, vigilant sentinels of the transient sky, tracked its motion, their wide-field cameras charting the comet's disintegration as it approached its closest solar embrace. Ground-based observatories joined the chorus. The Very Large Telescope in Chile's Atacama Desert, its mirrors uniting to resolve faint details. The Gemini South, slicing light into spectral clues. And the Nordic Optical Telescope, passing the object's fading glow from distant isles. This collective gaze, a tapestry of human curiosity woven across continents, sought to capture the essence of 3I Atlas before it slipped back into the interstellar night. Its decay a poignant reminder of time's unyielding march. Spectroscopic studies became the keystone of this investigation, each beam of light a scroll inscribed with the object's chemical secrets. As 3I Atlas neared the sun, its surface ices sublimated, releasing clouds of gas and dust that glowed under stellar scrutiny. Instruments like the Gemini North spectrograph and the James Webb Space Telescope's infrared sensors dissected this light, revealing carbon dioxide as the dominant volatile, its abundance dwarfing the water ice typical of solar system comets. The coma, a diffuse halo enveloping the nucleus, shimmered with reddish dust, its hue suggestive of organic tholins, complex molecules forged by cosmic rays over eons of travel. Nickel lines appeared in the spectra, an unusual metallic presence that hinted at a parent star richer in heavy elements than our own sun. Faint emissions of diatomic carbon and cyanogen lent the Tyler spectral green, a ghostly tint observed from the Canada-France-Hawaii telescope, evoking visions of alien auroras born from molecular dissociation under solar ultraviolet rays. These analyses, conducted in real time as the object brightened to a peak magnitude near 12, offered a window into its composition, yet each datum deepened the mystery. A comet both familiar and foreign, its chemistry a bridge between our system and an unseen stellar cradle. Comparisons with solar system comets unfolded like a dialogue between kin and stranger, revealing harmonies and stark contrasts. Like the long-period comets of the Oort cloud, Hale-Bopp or Hyakutake, 3I Atlas bore carbon-rich dust, its grains laced with silicates and organics that mirrored the irradiated surfaces of Kuiper belt objects. Waterous though present, played a secondary role, echoing the volatile profiles of comets like Borrelli, where dust dominates the coma's glow. These similarities suggested universal processes: the condensation of ices in cold stellar disks, the sculpting of surfaces by galactic radiation. Yet the differences were profound. The carbon dioxide to water ratio, soaring to 8:1, far exceeded the 1:10 typical of solar comets, implying a formation environment where carbon-rich volatiles thrived. The object's fragility stood out. Its nucleus splintered earlier and more extensively than Borisov's, fragments carving like icebergs from a melting glacier, a pattern captured by Hubble's time-lapse sequences. This disintegration suggested a porous, loosely bound structure, perhaps assembled in a low-density disk where gravitational compaction was minimal, unlike the denser environments that forged our system's comets. The nickel enrichment, rare in solar analogues, pointed to a stellar nursery infused with supernova remnants, its heavy elements woven into the comet's matrix. These contrasts painted 3I Atlas as a relic of a different cosmic epoch, its origins a puzzle that stretched beyond the familiar. The deeper mystery coalesced around its formation, a question that hung like a star veiled by cosmic dust. Did 3I Atlas emerge in a colder environment than Borisov, its predecessor, whose carbon monoxide richness suggested a distant, frigid birth? The dominance of carbon dioxide in 3I Atlas's coma suggested condensation in a disk's outer reaches, perhaps around a red dwarf star, where lower temperatures favored the freezing of such volatiles over water. Red dwarfs, comprising 70% of the galaxy's stars, host tight habitable zones but expansive snowlines, allowing carbon-rich ices to form at distances where solar system comets might favor water or ammonia. Alternatively, its parent star could have been smaller, dimmer, its weaker radiation preserving delicate ices that larger stars would vaporize. Yet the harshness implied by its fragility suggested a turbulent birth, perhaps in a binary system where gravitational chaos ejected loosely bound aggregates into the void. Simulations of such environments, drawn from studies of young stellar clusters, propose that close stellar encounters disrupt cometary clouds, flinging objects like 3I Atlas into interstellar exile with minimal processing. Its high volatile content, outgassing far from the Sun at over 3 astronomical units, hinted at internal heat, possibly from radioactive decay or stored energy from a prior stellar flyby, further distinguishing it from Borisov's more stable structure. These speculations wove a narrative of diversity. A galaxy where comets form under myriad conditions, each a unique artifact of its star's nature and history. The puzzle of invisibility cast a shadow over these inquiries, as 3I Atlas's faintness cloaked much of its story in obscurity. Its peak brightness, barely discernible at magnitude 12, demanded the most sensitive instruments, yet as it receded beyond Mars' orbit by December 2020, its signal dwindled, merging with the stellar backdrop. Unlike brighter solar comets that linger in elliptical orbits, this interstellar traveler offered only weeks of clarity, its rapid departure frustrating efforts to resolve finer details. Archival searches, like those from the Transiting Exoplanet Survey satellite, revealed early outgassing at distances where solar heating should be negligible, suggesting a hyperactive nucleus driven by internal dynamics. Yet the data gaps, missed spectral lines, unresolved fragments, left astronomers grasping at shadows, their questions multiplying. Could the green tint indicate exotic carbon chains, precursors to life's building blocks? Did the nickel suggest a supernova-enriched birthplace, or merely surface leaching during its galactic odyssey? The object's ephemerality evoked a poignant reflection. Like a fading echo, it revealed only fragments of its tale, leaving humanity to ponder the limits of observation in the face of cosmic transience. As the investigation deepened, patterns of fragility emerged. The comet's disintegration, a choreography of collapse. Time-lapse images from the Lowell Discovery Telescope showed chunks detaching, their trajectories fanning out like petals in a cosmic wind, indicative of low tensile strength. Unlike solar comets, which often survive multiple perihelion passages, Atlas shattered early, its porous matrix succumbing to thermal stress or tidal forces as it neared 0.8 astronomical units from the Sun. This fragility suggested formation in a gentler environment, perhaps a sparse disk where gravitational binding was weak, or a region shielded from stellar radiation, preserving volatile rich aggregates. Speculatively, such a structure could imply a galaxy teeming with delicate wanderers, their survival dependent on the cold stasis of interstellar space, only to unravel under the scrutiny of a foreign star. The emotional undercurrent swelled, a sense of awe at the object's ancient journey, tempered by sorrow for its dissolution, as if the universe offered a gift too fragile to hold. The philosophical weight of these findings pressed upon the scientific community, each spectral line a verse in an unfinished poem. If 3I Atlas formed in a colder, dimmer system, it suggested a galaxy of varied stellar nurseries, where chemical legacies diverged like dialects in a shared language. Its carbon dioxide dominance and metallic trace hinted at a star unlike the Sun, perhaps a red dwarf, its faint glow fostering isses that our warmer Sun would boil away, or a metal-rich giant, its disk saturated with supernova debris. The possibility of exotic molecules, polycyclic aromatic hydrocarbons or fullerene cages, stirred visions of panspermia, where such comets seed distant worlds with life's precursors, linking Earth to alien systems in a shared biochemical ancestry. Yet the invisibility of its full story underscored a deeper truth. Humanity's tools, though powerful, capture only glimpses of these transients, their secrets slipping away like whispers in the wind. As 3I Atlas faded, its legacy endured in the questions it posed, each a spark in the dark of cosmic inquiry. The global effort to study it, telescopes synchronized across hemispheres, data streams converging in shared repositories, reflected humanity's unity in pursuit of the unknown. The comet's fragility, its unique chemistry, and its elusive nature challenged models of galactic dynamics, suggesting a universe where interstellar exchanges are common, yet each visitor is a singular artifact. In its disintegration, it mirrored the fragility of understanding itself, urging reflection on humanity's place, a species poised on the edge of discovery, peering into the void, seeking meaning in the fleeting dance of cosmic exiles. In the boundless night where stars gleam like scattered embers of a forgotten fire, the third interstellar visitor, a fragile wanderer unveiled by a telescope beneath the Hawaiian sky, casts a shadow of mystery that deepens with each revelation. Named for the vigilant system that glimpsed its fleeting passage, this object, detected in April 2020, drifts through the solar system with a fragility that unsettles the mind. Its delicate structure, a whisper of the transient nature of cosmic travelers. Unlike the sturdy relics of our own system, bound by the Sun's eternal pull, this visitor, with its faint coma of dust and sublimating ices, appears poised on the edge of disintegration. Its nucleus, perhaps no larger than a kilometer across, crumbling under the gentle caress of solar warmth. Observations from mountaintop observatories reveal a body that sheds material with each passing day, its reddish glow hinting at ancient carbon compounds, yet its tenuous form suggests it may not survive its journey intact. This fragility raises haunting questions, like ripples spreading across a still pond. Are most interstellar objects so delicate, forged in the cold voids of space, that they shatter when kissed by a star's light, eluding humanity's grasp forever? The implications of this vulnerability unfold like a scroll of ancient warnings, each line deepening the enigma of the galaxy's hidden currents. If this visitor's frailty is typical, as inferred from its rapid dimming in telescopic data, then countless others may drift through the interstellar medium, too weak to endure the gravitational slingshots or radiative assaults of stellar encounters. Models of cometary dynamics, grounded in observations of our own system's icy bodies, suggest that such objects, formed in the outer reaches of their parent stars, lack the cohesion of inner system asteroids. Their ice is loosely bound by gravity and chemistry. When warmed, as this object now is at a distance just beyond Mars, volatiles like water and methane vaporize, fracturing the nucleus in outbursts that scatter dust into ephemeral clouds. Spectra captured by large telescopes in Chile and Hawaii show these bursts as spikes in brightness, yet each event erodes the object's core, threatening to reduce it to a diffuse haze before it exits our skies. Philosophically, one reflects on this impermanence. These wanderers, born in the crucibles of distant stars, may be destined to dissolve, their stories lost to the void, unless caught in the fleeting moment of detection. The suspense builds. Will this fragile messenger yield its secrets before it fades? Or is it but a glimpse of a vast unseen procession too delicate for our instruments to hold? The scale of this phenomenon escalates, casting a vision of a galaxy teeming with silent travelers, invisible until their final shattering dance near a star. Theoretical frameworks, built on simulations of planetary formation, estimate that trillions of such objects, comets, asteroids, and hybrids, populate the interstellar medium, ejected during the chaotic youth of star systems when giant planets migrate or stellar neighbors disrupt fragile orbits. Data from wide-field surveys, scanning the heavens night after night, suggest that our solar system may encounter one detectable interloper every few years, with countless smaller fragments slipping through unnoticed, their faintness masked by the stellar glare. If these objects are common, as population models predict, then the galaxy becomes a vast sea of debris, its currents carrying the remnants of shattered worlds across light years. Credibly, each star contributes to this diaspora, its outer belts of icy bodies flung outward by gravitational perturbations, as observed in young stellar clusters where disks glow in infrared light. This cosmic traffic, invisible until it grazes a star's radiance, evokes a speculative fear. Humanity may be missing a torrent of ancient relics, dust clouds, microcomets, even rogue planets drifting everywhere, their numbers dwarfing the visible stars. The emotional weight of this realization stirs a quiet unease, as if the universe conceals a restless undercurrent, its fragments whispering of forgotten cataclysms. The mystery deepens with the stark diversity of these interstellar visitors, each one a unique envoy defying expectations of uniformity. The first, discovered in 2017, was a rocky enigma, its elongated form tumbling without a trace of gas or dust, its surface hardened by eons of cosmic radiation. Its anomalous trajectory and lack of coma sparked debates, with some speculating on artificial origins before natural explanations. Perhaps a fragment of a tidally disrupted body prevailed. The second, arriving in 2019, proclaimed its cometary nature with a vibrant tale, its outgassing of water and carbon monoxide, revealing a chemistry akin to our own system's comets, yet enriched with alien isotopes. Now this third visitor, fragile and transient, bridges these extremes. Its faint coma and reddish hue suggest a blend of icy and carbonaceous materials, yet its rapid disintegration sets it apart. Her delicate relic, unable to withstand the sun's scrutiny. Spectral analyses, published in astronomical journals, highlight this diversity, showing compositions that range from silicate-rich to volatile-heavy, each object a snapshot of its parent system's unique history. One contemplates the philosophical implications. What does this variety reveal about the galaxy's tapestry? If every star system produces such distinct wanderers, scattering them into eternal exile, then the Milky Way becomes a mosaic of infinite narratives, each fragment a story of formation, disruption, and survival. This diversity speaks to a galaxy where no two stars craft identical legacies, their debris as varied as the worlds they birth. Models of planetary system evolution, informed by exoplanet surveys, suggest that stars of differing masses, red dwarfs, sun-like giants, or massive behemoths, forge unique environments. Red dwarfs, the galaxy's most numerous, may eject icy comets from tightly bound disks as their habitable zones hug close, while massive stars observed in their death throes scatter rocky fragments during supernova-driven chaos. Binary systems, comprising half the galactic census, amplify this process, their gravitational dances hurling material into hyperbolic orbits. The third visitor's reddish spectrum, aligned with carbon-rich bodies in our own distant belts, hints at a formation in a cold, organic-rich disk, perhaps around a star long evolved or extinguished. Speculatively, if such diversity is universal, then each star's exile carries a signature: metals from supernova remnants, ices from frozen nebulae, or even organic mantles from water-rich worlds. Emotionally, this evokes a sense of cosmic kinship, as if the galaxy's stars, though separated by light years, share a common act of dispersal, their fragments weaving a web of connection across the void. The escalating questions pile like shadows at twilight, each one deepening the enigma of this cosmic ecology. Are most interstellar objects so fragile that they elude detection, disintegrating into dust before reaching our telescopes? The third visitor's fading brightness, tracked through nightly observations, suggests a nucleus fracturing under thermal stress, its particles scattering into a diffuse cloud that may never be studied intact. If typical, this fragility implies a galaxy filled with ephemeral ghosts, their presence felt only in the rare moments of encounter. Credible extrapolations from cometary breakup studies suggest that only the most robust survive stellar passages, skewing our sample toward outliers. Philosophically, this raises a haunting possibility. Humanity may stand amid a torrent of unseen wanderers, their shattered remnants forming a cosmic haze that shapes planetary atmospheres or seeds distant worlds. The fear intensifies with the thought of larger objects, kilometer-sized comets or rogue moons, lurking undetected, their hyperbolic speeds posing impact risks with scant warning. Planetary defense models, tested against solar system threats, falter against such velocities, where months of notice shrink to weeks. Yet, the speculative fear gives way to a deeper wonder, a reflection on the galaxy's relentless creativity. If each star system produces unique exiles, as the trio of visitors suggests, then the Milky Way is a crucible of infinite variety, its debris a testament to the chaotic beauty of creation. The first visitor's rocky resilience, the second's volatile exuberance, and the third's fragile transience paint a picture of a galaxy where every star tells a distinct tale, its fragments scattered like seeds on a cosmic wind. Astrobiological implications linger. Could these objects, especially those rich in organics, carry life's precursors as panspermia theories propose? The second visitor's water-rich emissions and the third's methane hints fuel this hope, suggesting that interstellar exchange might knit biological networks across stars. Emotionally, this evokes a profound connection, as if Earth's own origins, its water, its carbon, bear the imprint of such wanderers, tying our existence to the galaxy's broader narrative. The mystery escalates as each discovery reshapes the scientific horizon, urging new strategies to capture these fleeting messengers. Space-based telescopes, proposed to scan in ultraviolet and infrared, could pierce the veil of dust, revealing populations of micro-comets or rogue planets. The third visitor's fragility underscores the urgency. To study these objects intact, humanity must act swiftly, perhaps launching interceptors to sample their ices before they dissolve. Philosophically, This challenge mirrors our own impermanence, a reminder that knowledge, like these wanderers, is transient, demanding we seize the moment. The galaxy's traffic, once invisible, now demands recognition, a call to expand our vision and embrace the unknown. In this deepening mystery, one senses the universe's restless pulse, its fragments weaving a tapestry of creation and loss. The third visitor, fragile yet laden with secrets, becomes a symbol of this cosmic dance, a fleeting arc that challenges humanity to look beyond its shores, to see the galaxy not as distant, but as an active presence in our skies. Emotionally, it stirs a quiet reverence, a recognition that we are not alone but part of a vast, interconnected cosmos, where every star's exile carries a story and every encounter a chance to read it. In the shadowed cradle of the cosmos, where stars ignite like fleeting sparks in an eternal night, the wanderer known as Three-Eye Atlas emerges as a relic from realms unseen. Its path, a hyperbolic arc etched across the void, speaks of a birth far from the sun's familiar embrace, a genesis in the frigid outskirts of an alien stellar system, where the raw materials of worlds congeal in silence. Astronomers peering through the lenses of telescopes perched on earthly summits have traced its trajectory backward through time, revealing a voyage that spans billions of years. This interstellar comet, discovered in the southern skies of 2025, arrives not as a conqueror but as a fragile envoy, its form a testament to the gravitational whims that propel such bodies into the galactic expanse. Consider the primordial nursery from which it likely sprang, the distant periphery of a foreign star's domain, akin to the Oort cloud that encircles our own sun, a vast reservoir of icy remnants from the dawn of planetary formation. In such remote belts, where temperatures plunge to mere tens of degrees above absolute zero, volatile ices accumulate around dust grains, forging comets through the gentle accretion of cosmic debris. Data from observances, including those by the James Webb Space Telescope, suggest that ʻOumuamua Atlas formed beyond the carbon dioxide snowline of its parent system, a boundary where gases like carbon dioxide freeze into solid mantles, enveloping rocky cores. This composition, rich in carbon dioxide with a ratio to water ice fur exceeding that of most solar system comets, hints at a birthplace cooler and more isolated than our Kuiper belt, where the stellar radiation was faint, allowing such volatiles to persist undisturbed for eons. The ejection from its home, a cataclysmic farewell, likely stemmed from the gravitational ballet of massive planets. In the turbulent youth of stellar systems, giant worlds like Jupiter analogues migrate inward, scattering smaller bodies in their wake. Simulations of planetary dynamics, informed by observations of exoplanetary systems through missions like Kepler and TESS, illustrate how these interactions can fling comets outward, with velocities sufficient to escape their star's grasp. For Three-Eye Atlas, with its inbound speed of nearly 58 kilometers per second, such perturbation aligns with models where a gas giant's close encounter imparts the necessary kinetic energy. Perhaps it grazed the atmosphere of a migrating behemoth, or was tugged free during a resonant dance with multiple planets, launching it into the interstellar medium like a stone skipped across a galactic pond. The southern origin of its approach, from the direction of Sagittarius toward the Milky Way's bulge, defies initial expectations. Most interstellar visitors were anticipated from the solar apex, the path of our sun's motion through the galaxy. Yet this anomaly underscores the diversity of ejection mechanisms, where stellar encounters in dense clusters could also play a role, as evidenced by dynamical studies tracing potential past interactions with nearby stars over millions of years. As the comet hurtled through the void, their relentless barrage of cosmic rays and interstellar dust may have further sculpted its form, eroding its surface and embedding it with the signatures of galactic travel. Its reddish hue, captured in spectral analyses from ground-based observatories, evokes the tholin-rich exteriors of distant solar system objects like Pluto, where ultraviolet light transforms simple organics into complex polymers. But 3I Atlas carries a fragility born of its volatile bounty, a matrix dominated by carbon dioxide ice, interspersed with traces of carbon monoxide, water, and even cyanide, compounds that, under the sun's intensifying glare, sublimate with dramatic haste. This composition renders it more susceptible to fragmentation than many of our local comets, which often boast denser, water-rich cores fortified by silicates. Observations from the Hubble Space Telescope reveal a teardrop-shaped coma of dust and gas, with ejection rates suggesting a nucleus no larger than a few kilometers across, shedding material at kilograms per second. The high carbon dioxide content, 8 times that of water, may stem from a formation environment where carbon-rich gases predominated, perhaps around a low metallicity star in the galaxy's thick disk, a stellar population older than our Sun, dating back to the universe's earlier epochs. Yet another thread in the tapestry of its origin posits 3I Atlas not as a pristine comet, but as a shard from a greater catastrophe. In the violent annals of planetary evolution, collisions between worlds can shatter moons or protoplanets, dispersing fragments into the stellar winds. Models drawn from the rubble of our own asteroid belt and the debris disks observed around young stars like Beta Pictoris suggest that such impacts generate swarms of icy detritus. For 3I Atlas, its depleted carbon chain molecules, lacking the dicarbon and tricarbon seen in many comets, could indicate a secondary origin, a piece torn from a larger body during a hypervelocity collision, exposing inner layers stripped of volatile organics. This fragmentation might have occurred in the chaotic aftermath of a planetary migration, where 2 ice giants clashed, or amid the tidal disruptions near a binary star system. The comet's high eccentricity and velocity support this narrative, as collisional ejecta often achieve escape speeds through the raw energy of impact. Spectral data from the Very Large Telescope, detecting atomic nickel and cyanide but no iron, further hints at a differentiated parent body where heavier elements settled inward, leaving the outer fragments enriched in lighter volatiles. This vulnerability, woven into its very structure, amplifies the philosophical undertones of its passage. What tales might such a fragile vessel carry from its shattered cradle? In the galaxy's vast archive, interstellar objects like 3I Atlas serve as scattered pages from distant stellar chronicles, each bearing the chemical imprints of their formative fires. Estimates from surveys like Pan-STARRS and the Vera C. Rubin Observatory project that billions of such wanderers traverse the Milky Way, ejected from the nurseries of countless suns. Their compositions, when compared to our solar system's relics, reveal the universality of cosmic chemistry. The same ices that seeded Earth's oceans may have condensed in myriad forms across the stars. 3I Atlas, with its ancient provenance potentially exceeding 7 billion years, older than our solar system if hailing from the galactic thick disk, embodies this archival essence. It whispers of stellar systems born in the universe's cosmic noon, an epoch of fervent star formation some 10 billion years ago, where heavy elements were scarcer, and comets formed with purer, more primordial mixes. Through its dust trails and gaseous emissions, we glimpse the building blocks that forged planets elsewhere, a mosaic of silicates, organics, and ices that mirror the raw ingredients of life-bearing worlds. Venturing deeper into speculation, yet grounded in the credible extensions of observed phenomena, one contemplates the role of such fragile bodies as harbingers of life's precursors. The concept of panspermia, the migration of organic compounds or even microbial life across the void, finds fertile ground in the travels of interstellar comets. 3I Atlas, laden with cyanide, carbonyl sulfide, and complex organics formed under cosmic ray bombardment could theoretically transport prebiotic molecules, the amino acids, nucleobases and sugars detected in meteorites like Murchison, which rained upon early Earth. Studies of cometary impacts, such as those modeled from the Rosetta mission to Comet 67P Churyumov-Gerasimenko, demonstrate how volatiles survive the rigors of space and atmospheric entry, potentially seeding barren planets with the chemistry of habitability. If 3I Atlas fragmented upon nearing a young world, its icy shards might deliver these essentials, catalyzing the emergence of biochemistry in primordial soups. This radical extension posits interstellar objects not merely as passive drifters, but as unwitting vectors in the galaxy's biological narrative, a slow, stochastic dissemination where life or its seeds hitchhikes on the winds of stellar ejections and at the horizon of speculation, where science brushes against the profound unknown. Arises the notion that such wanderings might not be entirely fortuitous. What if fragments like 3I Atlas bear the subtle hand of intent? The hypothesis of directed panspermia, first articulated by pioneers in molecular biology, envisions advanced civilizations deliberately propelling biological payloads into the cosmos, not as mechanical probes, but as chemical seeds encapsulated in resilient cometary forms. Drawing from the resilience of extremophiles, which endure the vacuum and radiation of space, as seen in experiments aboard the International Space Station, one imagines engineered microbes or prebiotic assemblages launched from a dying world, timed to intersect habitable zones. For 3I Atlas, its unusual southern trajectory and high carbon dioxide content might, in this extreme lens, suggest a tailored composition, carbon dioxide as a propellant for outgassing, ensuring dispersal upon solar approach. Though dismissed by most as improbable, its natural spectral signatures aligning with cometary norms, this philosophical extremity invites reflection on our place in the cosmic order. If intelligent beings once seeded the galaxy thus, we ourselves might be the echoes of such an act, our biosphere a legacy of interstellar benevolence or desperation. In this contemplative gaze, 3I Atlas transcends its material form, becoming a mirror to humanity's quest for origins. As it streaks toward perihelion in October 2025, its closest brush with the Sun at 1.4 astronomical units, the comet's activity intensifies. Dust grains from micrometers to millimeters eject at meters per second, forming a tail that stretches like a spectral banner. Observations from missions like SphereX and SWIFT capture this evolution, revealing emission rates of gases that peak and wane, a final flourish before its outbound fade. The nucleus, veiled in a coma of reddish dust, may crack under thermal stress as Borisov did before it, scattering remnants that could one day intersect another system. This disintegration echoes the impermanence of all cosmic travelers, reminding us that even the galaxy's archives are ephemeral, pages dissolving in the solar fires. Yet in their transience lies profound beauty. Each interstellar intruder, like 3I Atlas, bridges the isolation of stars, carrying whispers of formation, collision, and potential renewal. From the cold belts of alien suns to the fragmentary births in planetary wrecks, their stories unfold in the language of ices and dust. Philosophically, they challenge the solitude of existence, suggesting that the seeds of worlds, and perhaps of life itself, drift eternally, weaving a tapestry where no system stands alone. As telescopes track its receding glow, merging with the zodiacal light, one ponders the messengers yet to come. Will they bear natural scars, or the subtle artistry of minds long vanished? The cosmos in its silent vastness holds the answer, a mystery unfolding one wanderer at a time. The comet's path, now curving outward, carries it toward the heliopause, the boundary where solar influence yields to the interstellar winds. Dynamical models predict its fragments may linger in the outer solar system, ensnared by Jupiter's gravity, or escape entirely, resuming the nomadic existence. In this dispersal, the philosophical resonance deepens in Atlas as a symbol of entropy's grace, where destruction begets new possibilities. Its volatile, rich nature, making it brittle yet bountiful, mirrors the delicate balance of cosmic creation, ices that endure the void only to yield their essence in warmth. Broader still, these objects compose the galaxy's grand ledger, each entry a snapshot of stellar diversity. The thick disk origin, inferred from its kinematics, places 3I Atlas among the ancients. Stars formed in the Milky Way's turbulent youth, their comets ejected amid galactic mergers. Spectral deviations, elevated carbonyl sulfide absent tricarbon, hint at formation in metal-poor environments where supernova enrichments were sparse, preserving primordial chemistries. This archive extends to panspermia's speculative shores. Cyanide, a precursor to amino acids, could catalyze reactions on distant worlds, as laboratory simulations of cometary impacts demonstrate. The comet's age, potentially predating our Sun by billions of years, elevates it to a cosmic elder, bearing materials from the universe's formative chapters. In the extreme vista, directed panspermia beckons as a poetic culmination. Envision civilizations, facing stellar demise, encoding life's blueprint in icy capsules, launched not with fanfare but as quiet legacies. By Atlas's steady activity, without outbursts, might suggest stability engineered for long voyages. Its high velocity, a deliberate boost from advanced propulsion. Though evidence favors nature's hand, its chromodynamics akin to solar comets, this horizon expands our introspection. Are we the progeny of such seeds, our DNA a galactic inheritance? As the comet fades, its legacy endures in data archives, fueling models of interstellar populations. The Vera C. Rubin Observatory, with its wide-field gaze, promises more discoveries, each peeling back layers of the unknown. In this pursuit, humanity confronts the mystery of beginnings, not just of comets but of existence itself. 3I Atlas, fragile and profound, departs as it arrived, a silent philosopher dissolving into the night, leaving us to muse on the interconnected fates of stars and souls. In this contemplative gaze, 3I Atlas transcends its material form, becoming a mirror to humanity's quest for origins. As it streaks toward perihelion in October 2025, its closest brush with the Sun at 1.4 astronomical units, the comet's activity intensifies. Dust grains from micrometers to millimeters eject at meters per second, forming a tail that stretches like a spectral banner. Observations from missions like SphereX and SWIFT capture this evolution, revealing emission rates of gases that peak and wane, a final flourish before its outbound fade. The nucleus, veiled in a coma of reddish dust, may crack under thermal stress as Borisov did before it, scattering remnants that could one day intersect another system. This disintegration echoes the impermanence of all cosmic travelers, reminding us that even the galaxy's archives are ephemeral, pages dissolving in the solar fires. Yet in their transience lies profound beauty. Each interstellar intruder, like 3I Atlas, bridges the isolation of stars, carrying whispers of formation, collision, and potential renewal. From the cold belts of alien suns to the fragmentary births in planetary wrecks, their stories unfold in the language of ices and dust. Philosophically, they challenge the solitude of existence, suggesting that the seeds of worlds, and perhaps of life itself, drift eternally, weaving a tapestry where no system stands alone. As telescopes track its receding glow, merging with the zodiacal light, one ponders the messengers yet to come. Will they bear natural scars, or the subtle artistry of minds long vanished? The cosmos, in its silent vastness, holds the answer. A mystery unfolding one wanderer at a time. The comet's path, now curving outward, carries it toward the heliopause, the boundary where solar influence yields to the interstellar winds. Dynamical models predict its fragments may linger in the outer solar system, ensnared by Jupiter's gravity, or escape entirely, resuming the nomadic existence. In this dispersal, the philosophical resonance deepens. Atlas as a symbol of entropy's grace, where destruction begets new possibilities. Its volatile, rich nature, making it brittle yet bountiful, mirrors the delicate balance of cosmic creation, ices that endure the void only, to yield their essence in warmth. Broader still, these objects compose the galaxy's grand ledger, each entry a snapshot of stellar diversity. The thick disk origin, inferred from its kinematics, places 3I Atlas among the ancients, stars formed in the Milky Way's turbulent youth, their comets ejected amid galactic mergers. Spectral deviations, elevated carbonyl sulfide absentric carbon, hint at formation in metal-poor environments, where supernova enrichments were sparse, preserving primordial chemistries. This archive extends to panspermia's speculative shores. Cyanide, a precursor to amino acids, could catalyze reactions on distant worlds, as laboratory simulations of cometary impacts demonstrate. The comet's age, potentially predating our Sun by billions of years, elevates it to a cosmic elder, bearing materials from the universe's formative chapters. In the extreme vista, directed panspermia beckons as a poetic culmination. Envision civilizations facing stellar demise, encoding life's blueprint in icy capsules, launched not with fanfare, but as quiet legacies. 3I Atlas's steady activity, without outbursts, might suggest stability engineered for long voyages. Its high velocity, a deliberate boost from advanced propulsion. Though evidence favors nature's hand, its chromodynamics akin to solar comets, this horizon expands our introspection. Are we the progeny of such seeds? Our DNA a galactic inheritance? As the comet fades, its legacy endures in data archives, fueling models of interstellar populations. The Vera C. Rubin Observatory, with its wide-field gaze, promises more discoveries, each peeling back layers of the unknown. In this pursuit, humanity confronts the mystery of beginnings, not just of comets, but of existence itself. 3I Atlas, fragile and profound, departs as it arrived, a silent philosopher dissolving into the night, leaving us to muse on the interconnected fates of stars and souls. In the quiet sanctuaries of observatories, where telescopes stand as silent sentinels against the velvet dark, humanity prepares for the next cosmic wayfarer. The interstellar object, 3I Atlas, its fragments now scattering into the void, has left behind a legacy of questions, its brief passage a fleeting verse in the galaxy's ancient song. As its faint glow recedes beyond the reach of Earth's instruments, astronomers turn their gaze forward, forging tools and strategies to capture the secrets of future wanderers. The race is on, not merely to observe but to intercept, to touch the relics of alien stars before they dissolve into the interstellar night. Across deserts and mountaintops, from orbiting platforms to the drawing boards of space agencies, a global endeavor unfolds, weaving a net of vigilance to ensnare the next emissary from the deep. This pursuit, driven by the ephemerality of 3I Atlas's visit, evokes a profound reflection. Each visitor is a cosmic missive, its story etched in ice and dust, demanding readiness, lest its tale fade into silence. At the heart of this preparation stands the Vera C. Rubin Observatory, a monument to human curiosity, rising from the arid slopes of Cerro Pachon in Chile. Its 8.4-meter mirror, paired with a digital camera of unmatched resolution, is designed to sweep the southern skies, capturing light from objects as faint as the most distant galaxies. When fully operational, its decade-long survey will map the heavens with a sensitivity that promises to unveil dozens, perhaps hundreds of interstellar objects each year, transforming rare encounters into a steady chorus of discoveries. Unlike its predecessors, which stumbled upon Oumuamua and Borisov through serendipity, This observatory will systematically hunt for hyperbolic trajectories, paths that betray origins beyond the Sun's gravitational embrace. Its early tests, conducted in 2025, demonstrated its prowess, resolving faint asteroids and transient events with a clarity that hints at its potential to detect smaller, dimmer wanderers perhaps no larger than a kilometer across. For 3I Atlas, archival images from its survey precursors captured the comet's early outgassing, revealing activity at distances where solar heat should scarcely stir ices, a clue to its volatile richness. Speculatively, such sensitivity could uncover objects with anomalous compositions, hydrogen ices, organic mantles, or even preserved biosignatures, prompting visions of a galaxy where interstellar exchanges are as common as waves on a cosmic shore. The observatory's promise stirs a quiet awe, a tool to rewrite the census of the void, yet a reminder of humanity's fleeting window to grasp each visitor's story before it vanishes. Beyond the Earth's surface, space agencies craft ambitious missions to bridge the gap between observation and encounter, chasing the dream of touching interstellar matter. The European Space Agency's Comet Interceptor, set to launch in 2029, embodies this aspiration, its design bold wager against the unpredictability of cosmic arrivals. Conceived for solar system comets, its architecture, a mothercraft with 2 deployable probes stationed at the Sun-Earth L2 point, offers flexibility to target an interstellar interloper if one appears. Positioned to wait for a dynamically new comet or an unbound object, it can redirect to a flyby within weeks, passing as close as 1,000 kilometers to capture high-resolution images, spectra, and dust samples. Its instruments, including infrared spectrometers and dust analyzers, are tailored to probe volatile ices and organic compounds, potentially revealing isotopic ratios that distinguish extrasolar origins from solar relics. For a body like 3I Atlas, such a mission could have sampled its carbon dioxide-rich coma, discerning whether its nickel abundance stemmed from a supernova-enriched disk or surface alterations during its galactic odyssey. The mission's adaptability evokes a philosophical resonance, a spacecraft poised in cosmic limbo, awaiting a messenger that may carry the chemistry of life itself, reflecting humanity's readiness to meet the unknown with open hands. NASA's concepts push further into the speculative frontier, envisioning dedicated interceptors for interstellar targets. The Interstellar probe, proposed by the Johns Hopkins Applied Physics Laboratory, aims to venture beyond the heliosphere, reaching 1,000 astronomical units in half a century, equipped to study the interstellar medium and any objects encountered en route. Its suite of plasma sensors, magnetometers, and particle detectors could analyze the dust and gas of an interstellar comet, offering in situ data on compositions untouched by solar influence. More agile proposals like solar sail chasers draw inspiration from initiatives like Breakthrough Starshot, but are tailored for solar system pursuits, using lightweight sails propelled by ground-based lasers to match the blistering speeds of hyperbolic objects. Workshops at institutions like the Keck Institute advocate rapid response architectures, spacecraft pre-positioned in orbit, launched within days of detection, using gravity assists from Jupiter to intercept targets before they fade. Such missions, speculative yet grounded in current technology, could have rendezvoused with 3I Atlas, collecting fragments of its fragile nucleus to probe for complex organics or isotopic signatures of alien nucleosynthesis. The emotional weight of these plans lies in their audacity, a species daring to chase the galaxy's exiles, tempered by the humility of knowing each encounter is a singular chance, lost if not seized swiftly. Current work builds a foundation for these ambitions, with spectroscopic archives serving as repositories of cosmic memory. Data from 3I Atlas, gathered by telescopes like the Very Large Telescope and the Infrared Telescope Facility, have been meticulously catalogued, preserving spectral lines that reveal carbon dioxide, water, and cyanogen emissions. These archives, shared through global networks like the International Astronomical Union's Minor Planet Center, enable cross-referencing with future visitors seeking patterns in volatile ratios or dust compositions. Dust analysis conducted on 3I Atlas's reddish coma identified silicate grains and tholins, suggesting irradiation over billions of years. Yet the nickel abundance, rare in solar comets, prompts models of formation in a metal-rich stellar disk. Computational simulations of its breakup, using data from Hubble's time-lapse sequences, reconstruct the comet's porous structure, hypothesizing a low-density aggregate formed in a sparse cold environment. These models, informed by studies of solar comet fragmentation, suggest 3I Atlas's fragility stemmed from minimal gravitational binding. Perhaps in a red dwarf's outer disk, where ice is condensed without compression. Speculatively, such analyses could reveal formation processes universal to interstellar objects, or unique anomalies hinting at exotic chemistries, perhaps carbon chains or prebiotic molecules, that link to life's origins. The search for extraterrestrial intelligence adds a deeper layer to this vigil, extending beyond distant stars to the wanderers themselves. Efforts to detect signals, traditionally aimed at stellar systems, now consider the possibility of anomalies in interstellar objects' behavior. Radio telescopes like the Green Bank Observatory scan for narrowband emissions from objects like 3I Atlas, seeking patterns that deviate from natural outgassing or dust scattering. The brief signal detected near Proxima Centauri in 2019, later attributed to terrestrial interference, underscored the challenge, yet fueled speculation. Could an interstellar object harbor dormant technology, a probe from an ancient civilization, or even unintentional markers of artificial origin? Oumuamua's unexplained acceleration sparked such debates, and 3I Atlas's early disintegration prompt similar questions. Might its fragmentation mask deliberate mechanisms, or simply reflect natural volatility? These efforts, though speculative, evoke a philosophical tension. The search for meaning in the void, where each object could be a silent relica, a beacon awaiting discovery, urging humanity to listen before the signal fades. The recognition of ephemerality drives this race, each visitor a transient guest, offering mere weeks to unravel its secrets. 3I Atlas, peaking in brightness before fragmenting near perihelion, vanished from clear view by late 2020, its faintness at magnitude 12 challenging even the most sensitive telescopes. Future objects, moving at similar hyperbolic speeds, will demand rapid response observatories like Vera-C. Rubin will provide early warnings, but only missions like Comet Interceptor or proposed interceptors can close the distance, sampling dust and gas before they disperse. Concepts like NASA's Bridge mission advocate for pre-built spacecraft, ready for launch within days, using advanced propulsion to match velocities up to 60 kilometers per second. Such readiness reflects a shift from passive observation to active pursuit, a recognition that each wanderer's story, its chemistry, its origins, its potential for life, slips away unless seized in the moment. The emotional undercurrent is one of urgency, tempered by wonder. Humanity, a fleeting presence in cosmic time, strives to capture the eternal. Each mission a testament to the drive to connect with the galaxy's exiles. As the tools sharpen and testing continues, the Vera-C Rubin Observatory's surveys will flood archives with candidates, each a potential key to galactic history. Comet Interceptor's probes awaiting their target stand ready to unveil subsurface ices, while NASA's visions of sail-driven chasers push the boundaries of possibility. Spectroscopic advancements, integrating machine learning to parse complex emissions, aim to detect biosignatures like amino acids, linking wanderers to life's potential diaspora. Global collaborations, uniting observatories from Chile to Hawaii, ensure no signal is lost. Their data streams a collective hymn to discovery. In this race, the mystery endures. Interstellar objects as couriers of the cosmos, their secrets poised to reshape humanity's understanding of its place. Each tool, each test, is a step toward deciphering their tales, a pursuit that mirrors the fragility and ambition of a species reaching for the stars. In the twilight of its passage, the third interstellar visitor, a fragile comet unveiled in the Hawaiian skies of April 2020, etched a fleeting arc across the heavens, its delicate form disintegrating under the sun's relentless gaze. Like a ghost summoned from the depths of the galactic sea, it flared briefly, its faint coma of dust and sublimating ices glowing with a reddish hue that whispered of ancient origins. Observed through the unblinking lenses of telescopes perched on volcanic slopes and desert peaks, its nucleus, perhaps no larger than a kilometer, began to fracture as it neared its closest approach, scattering particles into a diffuse veil that shimmered against the stellar backdrop. This transient wanderer, born in the cold forges of a distant star system, burned away in our sky, its dissolution a poignant reminder of the impermanence that binds all things in the cosmos. Spectral data, captured by observatories in Chile and Hawaii, revealed traces of water, methane, and carbon-rich compounds, hinting at a composition forged billions of years ago, now unraveling in a final silent act. As it faded, its ghostly trail evoked a poetic imagery, a messenger from another world, reduced to dust, yet carrying in its fleeting presence the weight of cosmic history, a story told in fragments that dissolve into the infinite night. Each particle of this disintegrating traveler is more than mere dust. It is a shard of history, a relic of a star system older than our own, now lost to the silence of the void. Theoretical models of planetary formation, grounded in simulations of gravitational dynamics, suggest that such objects are castaways from the turbulent youth of their parent stars, when giant planets or stellar encounters hurled icy bodies into interstellar exile. The reddish tint of this comet, aligned with the carbon-rich relics of our own distant belts, points to a birthplace in a cold, organic-rich disk, perhaps orbiting a red dwarf or a massive star, long since evolved into a white dwarf or supernova remnant. Isotopic analyses, though limited by the object's faintness, hint at heavy elements, perhaps forged in ancient stellar explosions, preserved through eons of travel through the interstellar medium. Philosophically, one reflects on the weight of this legacy. Each fragment, no matter how small, is a chronicle of creation, bearing the scars of cataclysms that shaped worlds before our sun ignited. Credibly, these particles could carry organic molecules, as found in cometary samples from our own system, suggesting that the building blocks of life, amino acids, sugars or nucleobases, might be universal, scattered across the galaxy like seeds on a cosmic wind. In their dissolution, they leave a silent testament, a reminder that history is not confined to stars, but woven into the smallest grains, each a story of origins lost to time. Humanity's position in this unfolding narrative shifts, a quiet revolution born of these interstellar encounters. No longer mere watchers of the stars, gazing passively at their distant fires, humanity finds itself touched by the galaxy itself, its fragments crossing the solar system's boundaries like letters delivered across eons. The discovery of this third visitor, following the rocky enigma of 2017 and the vibrant comet of 2019, marks a turning point. The Milky Way is no longer a remote tapestry, but an active presence, its debris weaving through our skies. Wide-field surveys, scanning night after night, reveal that such objects may visit more frequently than once imagined, perhaps one every few years, for those bright enough to detect, with countless smaller fragments slipping through unseen. Models of galactic dynamics estimate trillions of such wanderers, ejected from every star system, forming a vast invisible current that binds the galaxy together. This new reality evokes a profound emotional resonance, a sense of connection to the broader cosmos. The stars, once distant monarchs, now send their envoys, their paths converging in our heavens, as if the universe in its vast indifference has deigned to acknowledge our presence. Philosophically, this shift challenges the notion of isolation, positioning Earth as a node in a galactic web, where matter's exchange transcends light years, knitting a shared history across the void. The emotional weight of this comet's passage lingers like a melody fading into silence, its brief existence a testament to the universe's restless creativity. Though it disintegrated quickly, its dust scattering into the solar wind, it left behind a truth that resonates beyond its physical form. We are part of a greater cosmic web, where even the smallest wanderer carries infinite meaning. Its reddish glow, captured in fleeting spectra, hinted at organic richness, sparking speculation that such objects might ferry life's precursors across the stars. Astrobiological theories, grounded in laboratory simulations of interstellar chemistry, propose that comets like this one could harbor complex molecules, resilient against the cosmic rays that bathe them for billions of years. If panspermia holds, as some models suggest, these fragments could seed habitable worlds, their ices melting upon impact to release organic payloads into alien oceans. The second visitor's outgassing of water and carbon monoxide bolstered this hope, and this third's faint emissions of methane and water vapor fuel, dreams of a galaxy where life's potential drifts freely, awaiting the right conditions to ignite. Emotionally, this possibility stirs a quiet hope, a vision of a universe teeming with latent vitality, where Earth's biosphere is but one note in a galactic symphony. Yet, the mystery tempers optimism with ambiguity as the comet's fragility raises questions that pile like shadows at dusk. Was it a sterile relic, its organic potential eroded by eons of radiation, or a vessel of life's seeds preserved in cryogenic slumber? The diversity of these visitors, each distinct in form and fate, deepens the enigma. The first, a rocky anomaly, defied cometary norms. The second, a robust comet, blazed with volatile richness. This third, fragile and transient, crumbled under scrutiny, its secrets dissolving before they could be fully read. This variety suggests a galaxy of infinite narratives, where every star system crafts unique exiles, their compositions shaped by the unique chemistries of their birth. Speculatively, some may be rocky shards from shattered planets, others icy comets from outer disks, and still others hybrids bearing the scars of stellar cataclysms. Philosophically, this diversity invites reflection on the universe's creativity. If each star scatters distinct fragments, then the Milky Way is a mosaic of stories, its wanderers carrying the signatures of their origins, metals from supernovae, ices from nebulae, or organics from water-rich worlds. The suspense of this encounter builds as the comet's disintegration unfolds, its fading brightness a race against time for astronomers seeking to capture its essence. Telescopic campaigns coordinated across continents track its outbursts, each flare revealing glimpses of its composition, perhaps water ice laced with carbon dioxide or methane clathrates, as inferred from infrared spectra. Yet the fragility underscores a haunting truth. Many such objects may elude study, their delicate forms shattering before detection, leaving only dust clouds to mark their passage. Credible models suggest that the interstellar medium teems with such ghosts, their numbers dwarfing the visible stars, a cosmic traffic invisible until it grazes a star's light. This unseen multitude evokes a speculative fear. Humanity may stand amid a torrent of ancient debris, microcomets, dust grains, even rogue moons, whose hyperbolic paths pose risks or promises yet unquantified. Planetary defense studies highlight the challenge. At velocities exceeding tens of kilometers per second, larger objects could strike with little warning, their energies rivaling cataclysmic impacts of Earth's past. Philosophically, this vulnerability mirrors our own, a reflection on humanity's fleeting tenure in the cosmic order. The comet's dissolution, observed in real time, becomes a metaphor for impermanence, a reminder that knowledge, like these wanderers, is transient, demanding swift action to grasp it. Yet, in this fragility lies a profound beauty, a recognition that meaning endures beyond physical form. Emotionally, the comet's passage binds humanity to the stars, its dust a shared legacy of creation and loss. Speculatively, if such objects are common, as population estimates suggest, then the galaxy is a dynamic crucible, its matter cycling through eons of dispersal and accretion, shaping worlds and perhaps life itself. The closing meditation lingers like a breath held in reverence, its imagery weaving the comet's arc into a universal truth. It came as a shadow, a faint glimmer from a star unknown, and left as dust, its particles scattering into the solar wind. Yet in its silence it spoke of connection, reminding humanity that we too are wanderers, bound to a star for now but destined one day to cross the gulf. The galaxy, once distant, now touches us, its fragments piercing our skies with silent urgency. In this encounter, one finds not just a scientific milestone but a philosophical awakening. Every star's exile carries infinite meaning, a story of creation that binds us to the cosmos. As the dust of this comet disperses, it leaves a legacy of wonder, a call to look beyond our shores and embrace our place in the eternal dance of the stars. In the hushed aftermath of cosmic intrusion, the wanderer designated as the third interstellar object, 3I Atlas, succumbs to the sun's unyielding embrace. Its nucleus, a fragile assemblage of ices and dust forged in the chill of distant voids, begins to fracture like ancient porcelain under the weight of inexorable heat. Fragments peel away in slow, deliberate arcs, each piece a splintered echo of the whole, trailing plumes of vapor that shimmer against the velvet backdrop of space. Telescopes across the globe capture this dissolution, the primary body, scarcely a kilometer across, shedding chunks that tumble into independent orbits, their surfaces erupting with sublimated gases, carbon dioxide, water and traces of cyanide, propelling them further into disarray. This breakup, observed through the keen eye of the Hubble Space Telescope, reveals not a resilient core, but a porous matrix, riddled with voids where cosmic rays have etched weaknesses over eons. The dust trail elongates like a fading scar, scattering sunlight into a diffuse glow that speaks of silicates and organics, materials that once clung together in the quiet of interstellar travel. This spectacle of fragmentation becomes a profound metaphor for the delicacy of knowledge itself. In the act of revelation, so much slips away. The opportunity to probe deeper layers, to sample unaltered ices that might hold isotopic signatures of a foreign star's nebula. Yet even in its demise, 3I Atlas imparts lessons that intact visitors might withhold. The rapid disintegration exposes interior compositions hidden from surface spectra alone, volatiles that vaporize at temperatures far below those endured by solar system comets, suggesting a structure more akin to a loosely bound aggregate than a monolithic ice ball. Observations from ground-based arrays in Chile and Hawaii document the cascade, initial cracks propagating under thermal gradients, amplified by the object's tumbling rotation, leading to a hierarchical breakup where larger fragments spawn smaller ones in turn. This process mirrors historical events, such as the disintegration of comet Shoemaker-Levy 9 in 1994, whose fragments plunged into Jupiter's atmosphere, lofting plumes that unveiled the gas giant's stratospheric chemistry and the dynamics of impact erosion. From such failures, science gleans the mechanics of cometary fragility, how tidal stresses and outgassing torques conspire to dismantle bodies, informing models of solar system formation, where primordial planetesimals collide and shatter, seeding debris disks with the precursors of planets. Indeed, the annals of astronomy abound with insights born from catastrophe. When comet Linear fragmented in 2000 nearing the Sun, its dissolution allowed astronomers to peer into subsurface ices, revealing ratios of deuterium to hydrogen that traced back to the solar nebula's conditions. Similarly, 3I Atlas's swift unraveling, dimming by magnitudes in mere weeks, highlights the vulnerabilities of interstellar travelers, their surfaces mantled in radiation-processed organics that crack under solar flux. This fleeting teacher, vanishing before a rendezvous could be mounted, underscores a timeless truth. Progress often emerges from the ruins of expectation. The data harvested from its death, spectral lines of sodium and potassium ejected in the fray, enrich simulations of interstellar object evolution, predicting that many such visitors may never survive perihelion intact, their legacies reduced to diffuse clouds, enriching the zodiacal light. In this, the cosmos reminds observers of the humility inherent in pursuit. Knowledge, like the comet itself, is ephemeral, pieced together from fragments glimpsed in passing. As the remnants disperse, a broader vista unfolds. The recognition that the Milky Way harbors an ocean of such wanderers, drifting unseen through the galactic expanse. Estimates derived from surveys like those conducted by the Panoramic Survey Telescope and Rapid Response System suggest that around the Sun alone, the density of interstellar objects reaches staggering figures, perhaps 1 per cubic parsec for bodies the size of 3I Atlas, scaling to trillions across the galaxy's disk. These nomads, ejected from their natal systems through gravitational perturbations, close encounters with giant planets or stellar flybys, populate the void like silent currents in a cosmic sea. The discovery of the first interstellar object in 2017, a slender shard tumbling at velocities unbound by solar gravity, opened this floodgate. The second, a volatile-rich comet in 2019, confirmed the diversity. Now the third, fragile and ancient, affirms the ubiquity. Dynamical models, informed by observations of exoplanetary systems via telescopes like the Transiting Exoplanet Survey satellite, posit that every star system sheds such debris during its formative chaos, flinging icy remnants outward at speeds of tens of kilometers per second. The galaxy, once perceived as vast emptiness punctuated by luminous islands, reveals itself as a dynamic medium, alive with invisible motion. Billions of these objects traversing the interstellar medium, battered by cosmic rays that transmute their surfaces into complex hydrocarbons, carrying the chemical heritage of their origins. Each wanderer serves as a bridge between stars, ferrying matter across gulfs that light itself takes millennia to span. In their ices and dust, they transport the elemental building blocks, carbon, nitrogen, oxygen, forged in stellar furnaces and dispersed through supernova remnants. Spectral analyses of similar bodies show organics akin to those in carbonaceous chondrites that have fallen to Earth, suggesting these interstellar couriers could redistribute the galaxy's metallicity, enriching nascent systems with heavy elements essential for rocky worlds. The motion is ceaseless, objects like 3I Atlas, tracing paths from the galactic thick disk, a realm of older stars formed billions of years ago, embody this exchange, their trajectories weaving through the spiral arms where new generations coalesce. The sea is not barren. It pulses with potential, each fragment a vessel of transformation, subtly altering the chemistry of the systems it grazes. In this interconnected web, the isolation of stars dissolves, replaced by a subtle communion, where matter flows like tides, binding the Milky Way into a singular, evolving entity. Venturing into the speculative yet grounded realms of astrobiology, one contemplates the possibility that these fragile bodies harbor more than inert chemistry, that they might scatter the ingredients of life itself across the galactic sea. Organics, resilient under the vacuum's chill, have been detected in cometary tails and meteoritic samples, amino acids, nucleobases and sugars, the precursors to biochemistry, surviving the rigors of space as evidenced by laboratory simulations replicating interstellar conditions. Panspermia, the hypothesis that life seeds migrate between worlds, finds credible footing in such findings. Comets, with their protective icy matrices, could shield microbial spores or complex molecules from radiation, as demonstrated by experiments exposing bacteria to the harsh environment aboard orbital platforms. If 3I Atlas, rich in cyanide and carbonyl compounds, building blocks for peptides and membranes, fragmented near a young planet, its shards might deliver these essentials via impacts, catalyzing reactions in primordial oceans. Evidence from Earth's geological record hints at this. Spikes in iridium and shocked quartz in ancient strata, linked to extraterrestrial influxes, coincide with evolutionary leaps, suggesting that cometary bombardments may have punctuated life's development. Could Earth itself owe its vital spark to such an interstellar gift eons ago? The theory posits that during the late heavy bombardment, some 4 billion years past, comets and asteroids, perhaps including interstellar interlopers, delivered volatiles and organics that filled the seas and ignited metabolism. Isotopic anomalies in terrestrial water and carbon, deviating from solar nebular expectations, bolster this notion, implying an external contribution. While not a certainty, panspermia reshapes perceptions of life's ubiquity. If organics traverse the stars' routinely then habitable worlds, may not forge life in isolation, but inherit it from the galactic commons. The discovery of extremophiles enduring space's extremes, bacteria revived after years on the lunar surface, lends credence, suggesting that life, once emergent, could hitchhike on cometary fragments, disseminating across systems. In this light, 3I Atlas's dissolution becomes a poetic dissemination. Its dust, potentially laden with prebiotic relics, scatters into the solar wind, a subtle infusion that echoes the galaxy's fertile undercurrents. This reckoning demands more than passive observation. It calls humanity to engage actively with these cosmic transients. Future endeavors, conceptualized by space agencies, aim to intercept and study such visitors before they evade grasp. The European Space Agency's Comet Interceptor, poised for launch in the late 2020s, will station itself at a stable point beyond Earth's orbit, awaiting discovery alerts to rendezvous with long-period or interstellar comets, deploying probes to sample their comets and nuclei. Proposals from institutions like the Southwest Research Institute envision dedicated missions, such as an interstellar comet explorer designed to fly by these objects at high speeds, capturing spectra and particles to unravel their compositions. These ventures, building on the legacy of missions like Rosetta, which orbited and landed on a solar comet, promise intimate encounters, analyzing ices for deuterium ratios that fingerprint distant stellar nurseries, or organics that hint at universal biochemistry. One day, humanity may not merely watch these wanderers pass, but harness their paths, perhaps attaching sails to outbound fragments, propelled by solar radiation to venture toward other stars, turning interstellar highways into conduits for exploration. In this evolution, humanity mirrors the cosmos's migratory essence, destined one day to cast its own fragments into the night. Probes equipped with laser sails, as envisioned in breakthrough initiatives, could achieve fractions of light speed, traversing light years in decades. or in bolder speculations, directed panspermia, seeding microbial payloads on outbound comets, disseminating terrestrial life to habitable exoplanets as a safeguard against extinction. Such acts would weave human legacy into the galactic fabric, transforming observers into participants in the eternal exchange. The temporal scale of 3I Atlas's Odyssey deepens this reflection. Its journey, reconstructed from orbital data, spans perhaps millions of years, ejected from a system in the galactic thick disk. It wandered through the interstellar medium at velocities around 50 kilometers per second, crossing voids where stars are sparse and time dilates in isolation. This passage evokes deep time, epochs where galaxies merge, stars ignite and fade while the object endures, its ices preserving snapshots of ancient chemistry. In glimpsing it, observers touch not merely another system's past but the universe's patient rhythm, where events unfold across scales that dwarf civilizations. The cosmos, indifferent to haste, teaches endurance. Humanity, with its brief flicker, is only beginning to attune to this cadence, listening through telescopes that pierce the veil of light years. In the silence that follows, 3I Atlas fades, its E, dust scattered to the heliosphere's edge, merging with the solar wind. The final weight settles, the wait for the next messenger, knowing each will be different, knowing each will change the beholders. They come from stars unseen, carrying questions older than humanity itself. And when they pass, they remind of shared essence. Wanderers fragile as dust, yet burning with the same fire that drives even the smallest fragment to cross the endless sea of stars.